Hi everyone, welcome to Solving Trig Equations, part 4, I think this one is. So we're going to start with these two and then we'll go back to the one that was just at the top of the page that I moved out of the way there. Okay, we're going to start with this one. Now this one, it's kind of like the one we ended with on the video previous. We have something inside here that is not what we're actually, is not just a theta or just an x. So I'm actually going to do the same thing I did before. I'm going to let this be true. And this is the thing I'm going to actually solve for. Okay, and again, if you know me, you know that I don't really rationalize these things. So to me, that's one that's actually harder to look at. I don't like to look at it that way. I'm going to think about it this way because this one makes more sense with the triangles to me. So I'm thinking about it this way. So now what I'm going to do is I'm going to go to my triangles. And again, I have them drawn out so that, this is the 4th video that I've done. And so, I'm getting tired. It's easy to make a mistake. But now I know I need the adjacent side to be the 1 and the opposite. So the adjacent side, opposite, see? I'm already screwing it up. The opposite is the 1 and the adjacent side is the √3, so it has to be this, right? So it's our pi over 6. So we know that u is equal to pi over, well, no, we don't know that, right? We know that the reference angle is pi over 6. Now, how am I going to figure out what the angle actually is I'm going to put it in the correct place. Now, I know I want it where tangent is negative. So that means not this quadrant, but this quadrant. So if I put pi over 6 here, we know that that one is actually 5 pi over 6. And the next place that we can find negative for tangent will be here. So that one's going to be 11 pi over 6. So these are the two angles that u is equal to. All right, but once again, u is not what I'm looking for. I'm actually looking for theta, okay? So if this is what u is equal to, well, theta plus 3 pi over 4, I'm just using my transitive property, has to be equal to 5 pi over 6. Not theta plus, and theta plus 3 pi over 4 has to be equal to 11 pi over 6. So in order to find these two angles, what am I going to do? I'm going to just solve for these two little equations. So I'm probably going to change this to, two things that are the same. So what would that be? 12s, I guess, would be a good one. So theta is equal to 22 pi over 12 minus, is that 9 pi, I want to say. So 22 minus 9, what do we get? 13. So 13 pi over 12 is actually the one that I'm looking for. And for this one, let me put this here, and let me do the next one down here. So this one, so now we want to subtract this from both sides. And again, I'm going to use 12, so this will be 10 pi over 12 minus 9 pi over 12. So this one is going to be a what? 1 pi over 12. So these are the two angles that I'm looking for. That's what theta is going to be equal to. So theta is equal to pi over 12 and 13 pi over 12. Now, if I'm looking between 0 and 2 pi, which again, for all of these, we've been doing 0 and 2 pi, and then we've been doing, all of them or whatever. So I could add my pi k to these. That's easy enough, right? And you can see, like, if you add pi k, you get both of those. But if we are doing between 0 and 2 pi, it is good to check, because if this gets shifted over enough, because remember, tangent is like this picture, but imagine that it gets shifted over enough so that it gets pushed, like some of the solutions gets pushed outside of my 2 pi, because, like maybe I'm shifting this to here, and so one of these solutions could get pushed out. Now I see that this is smaller than 2 pi, so that's fine, and this is smaller than 2 pi. A lot of times what will happen is you'll actually end up with a negative one, and you'll have to find the next closest one. So if my answer had come out negative pi over 12, what I would have done is I would have kept adding 2 pi to it till I found one that was positive. Does that make sense? Does everyone know what I mean? Again, maybe I can do some of those ones later. This is the last video I think I'm going to put up for now, but I can do some more, especially if you ask some questions. Tell me which ones you want to see. And 13 pi over 12. Now, I know that if I add 2 pi, well, for tangent, it's pi. But if I add pi to this, so that would be another 12. That one will be too big. That one will be 25 pi over 12, right? So that one will be too big, but just by a little tiny bit. Do you see that? So, and then, you also sometimes want to check the other way too. If you subtract 12 pi over 12, will you still be bigger than 0? Now, most of the time when you shift it this way, there's still only going to be 2 solutions. You're only going to get 2 solutions. And when you get 2 positive ones, you're usually pretty good to go. But just so you know, that can happen. You can get one that's too big. If it's outside of the 2 pi, then you're going to subtract 2 pi and find the one that's inside 2 pi. Or if you get a negative one, you get one that's too far on this side, then what you have to do is you have to add 2 pi to find the right ones. Okay? So once again, if you don't really know what I'm talking about, make sure you send me a message about it so that I can help you out with that. Okay? So this next one is secant negative 2 theta is equal to negative root 2. Okay. So again, what do we do here? I'm going to think about it that same way that we've been thinking about them. I'm going to say secant u is equal to negative root 2. So which triangle should I be thinking about? Well, hopefully everyone knows it has to be this one, right? So we want the adjacent, the hypotenuse over the adjacent, the hypotenuse over the adjacent. So obviously it doesn't matter which one we're talking about here. It's pi over 4, right? So my reference angle is pi over 4. But I got to draw it where cosine is negative, because cosine is the reciprocal of secant. So not here, but here. So that's 3 pi over 4. And then here, so that one is 5 pi over 4. Okay, but that's what u is. So u is equal to 3 pi over 4 and 5 pi over 4. So once again, we'll do it between 0 and 2 pi. Let's say that that's what they asked us, between 0 and 2 pi. And then we'll do all of them also. Okay, so if we're doing it between 0 and 2 pi, we know that that's what u is equal to. But we know that u is equal to negative 2 theta. So if we put negative 2 theta in here, this is the thing we actually want to find. We want to find theta. So we know that this one is going to give us theta is equal to, if I use the 2, right? If I use the negative, I mean negative 3 pi over 8. And this one's going to give us negative 5 pi over 8. Now this brings me to that thing that I was just talking about. We can clearly see these are not between 0 and 2 pi. Okay? So what do I do about that? Well, for this one, this is the one where I have to go back because we can see that this has a period change. Okay, so sometimes I figure this out first. It's like the first thing that I do. So the period for secant is usually 2 pi, but this is going to have a horizontal compressed by a factor of 1/2, which means we're going to cut that period in half. So my period is actually going to be 2 pi divided by 2, which is just pi. So to get to the angles that I'm talking about here, ones that are going to be useful to me, what I'm going to do is I'm going to keep adding pi, which I'm going to write as 8 pi over 8, and I'm choosing that because these are in 8s. Okay? So I'm going to add 8 pi over 8. And the first one is going to be, what is that, a 5 pi over 8? Now that's a good one. I want that one. That's between 0 and 2 pi. Now, once again, because this has been squished, I'm expecting to see twice as many waves inside the same amount. So where we normally had 2 solutions, I'm expecting to find 4. Okay? Because this has caused that compression. So there's going to be twice as many waves in the same amount of space. I'm going to keep going. I'm going to add another 8 pi over 8. So 8 plus 5, I want to say that that's a 13. Is it? I think it, yes. Okay. So that gives us our 13 pi over 8. So that's another good one, between 0 and 2 pi. Now, hopefully you know well, I shouldn't do that, right? I shouldn't put them equal like that. That's awful. That's awful form. But I'm going to cross these out because that's terrible to do because those are not all equal things. So they should not be all equal. I think I did it in the last video and I just realized what I did there. I usually do them downways, but it's hard to do it downways on these videos. So that was terrible. I just caught it now though. So if you watch the other videos, I hope that you noticed that was terrible, terrible form. Okay, 8 and 13 is 21 pi over 8, which is too big, right? So it's just this one and this one. All right, now I'm going to do the same thing here. I'm going to do my 5 pi over 8 plus 8 pi over 8. And that one is going to give me a 3 pi over 8. And of course, so hopefully you noticed if I had just dropped the negative here, I could have done it that way. But you don't want to drop the negative if it's, because you can have, like if there was a plus pi over 7 or something, it would make a difference in the answer. So I didn't drop it. But if you had, you would have ended up with the same thing. So here I want to add 8 pi over 8, and that will give me 11 pi over 8. So that's another good one. And hopefully, if you add another 8, that'll be 17 pi over 8 will be too big. So if we're just doing between 0 and 2 pi, we have 5 pi over 8. And what was the other one that we had there? 13 pi over 8. Then we had 3 pi over 8 and 11 pi over 8. Those are my 4 solutions. And if I'm doing all of them, then I'm just going to write the little expression that describes what we just did here to find all those angles. We did 5 pi over 8 plus pi and 3 pi over 8 plus pi. Right, so this would be all, and this would be between 0 and 2 pi. Okay. Now there's one more that I want to do this video, and then we'll wrap up our video series here, like I said, until I get some questions about ones that you want to see, because there's lots and lots of other ones that maybe you want to see, but I'll wait for you to tell me what they are before I do a whole bunch more of these. All right. Well, let's take a look at this one. Now this one's a little different because I have a cosine 2 theta and I have a cosine theta. Now there's no way for me to factor this out. If I could factor it so that I would have them as multiplied together, I could work with each one separately. So that was one of our strategies before. But there's really no way to do that here. So guess what we're going to have to do here? Can you guess? We're going to have to use our double angle formula. And I happen to have mine sitting here. So I'm going to use my double angle formula. I can use this one, or you could change this to all sines and all cosines or whatever you like. I almost always just do this one first and then just change it the way that I want it afterwards, because that's the one that I always remember. So I'm going to go ahead and I'm going to change this to cosine squared theta minus sine squared theta plus 3 cosine theta. Now hopefully you know what you really want is just cosines, because I have a cosine here. So if you had changed this to the 1 minus cosine right away, but like I said, I don't really usually bother to waste the brain energy trying to figure out those other ones, because I know it's easy to change it to this real quick. Because the other way you can think about it is I'm just using my Pythagorean identity now. So we have 2 minus, is equal to negative, is that what it said? Yes, okay. Cosine squared theta minus 1 plus cosine squared theta plus 3 cosine theta. And so that gives us that 2 cosine theta minus 1, which is so you could have just jumped to that one if you knew right away that you wanted it to be cosine. And you probably did, because this is one that you wouldn't want to change. So you probably knew that you wanted it all in cosines. Okay? So I distributed this negative at the same time. So this would have been a positive 2 cosine, so he became negative, and the 1 became positive. All right, so now I can see that this looks quadratic to me. I don't know about you, but it's screaming out that, I should be thinking quadratically. So I'm going to make it negative 2 cosine theta plus 3 cosine theta, and that will give me what, a negative 1? And again, I don't like that negative in front, so I'm going to go ahead and divide everything by -1, including the 0. So that makes it legal for me to do that. And now I'm praying that it's factorable. I need it all to be negative. Yeah, that one works out. I have seen some of these where you have to use quadratic formula. So don't be surprised if you do. If you get one that you have to use quadratic formula, it's not factorable, then I highly suggest that you let like u equal cosine theta and then just do it that way. So then you make it use your quadratic formula on this thing, but then when you get to the end, like you'll have plus or minus the square root of something all over something, right? Remember that you'll have u, but you have to change that back to cosine. Okay, so if you do have to do quadratic formula, I suggest that you do this. That makes it a lot easier. You know that you're solving for u, not for cosine, right? So then you have to go back and replace it. But anyway, okay, back to this. Okay, so now I'm going to set each of these equal to 0. All right, and again, if you have your things sitting in front of you, you can just pull them out instead of having to think about it. So a half, I know it's this one. I want the 1 to be adjacent, so it's this guy. So this one's pi over 3 is my reference, right? And this one is 1. So that means it's this one. So let me see how I wrote it. Oh, did I say this time? No. So let's do it this way. So that means I'm going to describe it as 0. So that will be 0. So that one is 0. This one is pi over 3, right? Because where is cosine positive? It's positive here, so I already know pi over 3 is one of them, so that's fine if that's positive. I know the reference angle is one of the choices. And then the other place it's positive is here, so that one's going to be, so it's pi over 3, 5 pi over 3, and 0. Once again, you might want to go back and check them out because we actually changed some stuff around here that wasn't true in the beginning. We stuck this in for that one. So whenever you use your identities to rearrange these, I always feel like it's a good idea to make sure that I didn't make anything, like I didn't get any extraneous solutions in there. If you feel like you're taking a test and you're running out of time and you really just don't have time, well, roll the dice and say, let's take the shot at it. But you're doing your homework, you have an extra 2 seconds to figure it out, right? So cosine of pi over 3 we just said was a half, so this is 3 halves. This is actually 2 pi over 3. So cosine of 2 pi over 3 is actually going to be in this quadrant, so it's going to be negative a half. So negative and negative will be a positive a half. And it looks like that one's going to work out. So we're good. So this one's good. All right, same thing. So 2, well, we know that one's going to work out. Do we? Oh, no, we don't know for sure. Hold on. Cosine of 10 pi over 3 plus 3. So that's putting the 5 pi in here. We know this one was a half. That's where we got that from. So 10 pi over 3, where the heck would that be, right? So this would be 6 pi over 3. This would be 9 pi over 3. So 10 pi over 3 must be here. Cosine is negative there, so that means that's going to be the negative 1/2 that we just said. Oh, sorry, this is 3 halves because of the 3. So that'll be another one. So that one works also. And then 0. So cosine of 0 plus 3 cosine of 0. And cosine of 0 and 0 is all 0. So that's 0 plus 0, which does not equal 2. So this is the one that's no good. It's a good thing we checked. This one's no good. You have to throw him away because cosine of 0 is 0. Cosine of 0 is 0 times 3 is still 0. So that's 0 plus 0. And this was negative, but negative 0, whatever. It does not equal our 2. So this one is no good. So whenever you're using your identities to move things around, that's another time when you can maybe create a situation where you have more solutions than you should. Okay, so I just checked that one for sure. So when do I definitely check the solutions? I check them when I square something, or I multiply through by the variable, I multiply through by a cosine, or I multiply through by a sine, or something. And when I use my identities to change them, you should definitely check your solutions then. All right. Best of luck. Make sure you let me know which ones you want to see. I'm willing to do out some more, but I'll wait for you to say which ones they are so that I'm not just doing out a bunch of ones that you already know how to do. Okay, good luck, guys. Do a good job.